Now we'll be working on this question, Fall 2011 Math 227 Test 1 number 14. By what I saw last time when I gave this question to my students, this is the question in which most students did not answer. Now, if we ask the reason why, it's very likely because the understanding. Okay, now let's see what we have here. Probability of A is 0.7, probability of B is 0.64, probability of A given B is 0.75. The first question is, what is the probability of the intersection? Now, what we have in number 13, if you saw number 13 earlier, we have very similar questions, but the one given to us at that time, not only probability of A and probability of B, but the probability of the union instead. Now, what happens if the one given to us right now is the probability of A given B? Now, let's recall a little bit. The hard part here is really about what do you understand from the formula. The formula that involves the four things here, actually only three of them necessary, is the following: probability of A given B is equals to the probability of D intersection over the probability of B. Okay, which if I modified a little bit, this is pretty much the probability of B times probability of A given B equals to the probability of A intersection B. And then from here we can plug in numbers. Now, plugging numbers is one thing. Let me plug it in first. This is 0.64 times 0.75, right, equals to the probability of A intersection B, which is equals to 0.64 times 0.75. I think that's 0.48. That's the probability of A intersect B. Now, before I move on to the next question, part B, I want you to think this thing. Okay, we can work with formula, but if you think a little bit further, you see that the probability of A intersection B can be seen from another point of view, that either probably the event A to happen first and then event B happen after that. Probability of A intersect B equals to the probability of A to happen first times the probability of B happen after A, right? Unfortunately, we don't have this thing. The one given to us is probability of A given B. Another way to look at this, we can see that, okay, let B happen first, then A happen after B. Okay, now see, this formula here is pretty much the same with what we have there. Okay, now so instead of remembering this formula, you can actually think a little bit and see how the events takes place. Okay, either A happen first then B, or B happen first then A. Now part B, the probability of the union A union B, that's equals to, that's the formula we usually use, probability of A plus the probability of B minus the probability of the intersection. Now you see again that this part B, the question here, is not doable without first doing part A. Okay, but anything from here, you just plug in numbers. This is 0.7 plus 0.64 minus 0.48, which if I compute further, let me write this down, probability of A union B that's equals to 1.34 minus 0.48. What is that equals to? 6, that's 9, 0.86. Okay, that's the probability of the union A union B. Now actually from here, if you want to think a bit further, then what is the probability that it is not A union B? In other words, if you imagine the Venn diagram, let's say this is event A and this is event B. Now A union B refers to the region inside A or B, right? Now how about the probability that not A nor B to happen? That's equals to 1 minus that thing, which is 0.14. Okay, now this question is harder than the questions you usually see in the book, even in my quizzes, but this is the question that not only makes you think, that really challenge your understanding on not only the formulas but also how those things work together. Okay, make sure you get this one.